Hi students, MCQ number 16. The ratio of RMS speed of ideal gas molecules at a pressure P to that at pressure 2P is to be determined. Now in this chapter kinetic theory of gases, almost this type of problems will be repeatedly asked in the competitive exams again and again, and we had been using the formula for the RMS velocity like this: V RMS is equal to square root of 3 RT by M. This is the formula used for molar mass of a gas, but the RT is here. In terms of pressure is to be determined. So PV is equal to RT for 1 mole. Therefore, this also can be written as VRMS is equal to 3 PV divided by M. So here you can see that for the same volume and the same gas, M is constant. So I can write VRMS. VRMS is proportional to square root of P. So this is the idea which is required. Now P1, initial pressure P1 is equal to P, and finally the pressure P2 has become what? Twice the pressure. So this is 2P. So V1, I can write V1, VRMS 1 is proportional to square root of P, and V2 is proportional to square root of 2P. So what is asked here? The ratio of the RMS speed V1 is to V2 is asked. Therefore, V1 divided by V2 is equal to square root of P divided by 2P. So that the pressure term gets cancelled. So this is equal to square root of 1 by 2. Therefore, V1 by V2 is equal to 1 by square root of 2, that is 1 is to root 2. So this is the ratio. So we can see which of the option is correct is C. Therefore option C is the correct answer. Now this is just the steps I am writing for understanding, but actually in the either board examination or competitive examination, for this you should not take this much time. Within 2 to 3 seconds, just as a mere look itself, you must solve such problems, because we know that the VRMS is directly proportional to P, is it not? So naturally when the pressure is doubled means it must be root 2 times only. So quickness is required, provided if you remember this relationship, understand that. So we have substituted and we have got the answer as 1 by root 2. Anyhow, for understanding we may go by these steps, but in the competitive exam quickness is very important. I hope you must have understood well. Fine.